Now got a red
Hi,
light.
my name's Jay Hafner, and you all have heard a lot of videos from me. You've seen a lot of stuff through the retrofit of the Kennex, but we have a real blessing right now. We have a visitor. His name is Bruce Wilson, and you'll know more about him in a few minutes. But basically what we're going to do is show you what the first production catamaran with electric propulsion from Dave Tether's design that started this whole process. And that was back in a few years back. Bruce will explain the whole details on that. But he's come to Marathon, Florida, in Marathon Marina and Boatyard to visit us and to help us with the final days before the Miami Boat Show and Strictly Sail. So here's the rest of it. Stay tuned. Enjoy the video.
Yeah, there.
Sort of sitting here, and you can be back over there.
Sounds like a plan, guys.
There we go.
Nice and bright. Okay.
You ready?
Yep.
Okay. This is Waypoint. This is the first production boat to have Dave Tether's electric drive system installed by a professional manufacturer. The boat was produced in 2003. It's a Lagoon 410 S2. Dave actually went to France to do the initial installation. There's a lot of anecdotal stories about that as to seeing him put these engines in with some batteries and the guys wondering, well, what do you do when the batteries go flat? Things like this. But the boat has now been in service for 7 years. It's spent 3 years with the Catamaran company down in Tortola. A lot of information out there on the web about its days in charter, about people drag racing against other boats that had 40 horsepower Yamahas and this boat just edging them out. It's one of the strange things people first need to understand about electric drives. These motors are only 12 horsepower. That is 12 real horsepower. And the torque generated by these engines is equivalent to about a 40 horsepower Yamaha. It's a lot more than what people anticipate. So when they hear 12 horsepower, they go, oh, that's tiny, it won't move the boat. Utterly wrong. In fact, I have never pushed this boat as hard as, never pushed the motors on this boat that will each take 100 amps. I've never pushed them that hard. I've never taken them above 60 amps. Why? Because I'm already up at whole speed at 60 amps. So during this time, the only service work I've had to actually do on the engines is none. But I've changed 2 of my controllers out, and that was because I was in a shipyard where they left the back hatches open and the boat got terribly humid. And you know, it was open for about 4 months, so we knew exactly why the controllers went. And they're about $1,500. Well, I've got 4 controllers, so it was very easy to identify what the problem was. But the basic system is the motor, a controller, a throttle at the helm, and a battery.
What do you have for batteries?
Oh, I've got a dozen 126 amp hour Odyssey batteries.
Are those an AGM or?
Yeah, they're an AGM. Now, the boat came with Lifeline 210 amp hour batteries. By changing down to the Odysseys, I pulled nearly 600 pounds out of the back of the boat. Now, what that did to me is I went from being able to motor for roughly 1 hour, just over 1 hour on battery, down to about 45 minutes. The trade-off was a bit different. Your normal AGM, you can rapid charge. You never want to take an AGM below 50% or 12 volts, because then it starts counting as a duty cycle against the battery and will limit the life of the battery. So you're operating the battery basically between 12 and 13.8 volts. So when you look at it, 210 amp hour battery, half discharge, you're down to 105 amps. But rapid charging, a normal AGM will only rapid charge to 85%. So the Odyssey batteries, they call them a pure lead battery, they'll rapid charge to 95%. So moving from 210 down to 126, I didn't actually lose as many usable amp hours as people believed. since I gained an extra 10% of capacity in the actual battery. But currently I can motor for about 45 minutes just on battery. Now, part of my reasoning in this was that I wasn't intent on saying, oh, I can go for a day running on batteries. I looked at it and said, well, how long does it typically take me to get comfortably off a dock, out, go sailing? Answer, 15 minutes, 20 minutes. So I was very content to know that I've got battery power enough to go out for a day sailing and come back without having to start anything else. The other maintenance work that we've had to do has been actually more to do with our shaft bearings. They got squeaky. The motor bearings, well, they're good for 100,000 hours. Currently, the motors have got 2,250 hours on them. So I've got more than the rest of my life to go on those. But I did change out my strut bearings because there was more noise coming from the strut bearings than there was from the engines. Well, oddly enough, they put in the new strut bearings, you can still hear a squeak. So they're still more noisy than the engines. The rest of my system, I've got a Fisher Panda 17.5 kilowatt 168 volt DC generator for charging the main battery bank. So that is kicking out roughly 120 amps. I've never seen actually the battery bank accept more than about 50 amps in rapid charge mode. But, which tells me that we could downsize the generator slightly. But that's maybe. Because if you're putting 50 amps back into the battery bank while you're still driving the boat, and typically at 30 amps an engine I'm doing about 6.5 knots. It starts getting expensive as you go up in power. In fact, let me grab my cheat sheet that was in here. We go. This will give you an idea. Okay. 3.8 amps an engine, I'm doing 3 knots. 5 amps an engine, I'm doing 3.8 knots. 10 amps an engine, I'm doing 5 knots. 15, I'm doing 5.5 knots. 20 amps, I'm doing 6 knots. 25 amps, I'm doing 6.5 knots. 30 amps, I'm doing 7 knots. 50 amps, I'm doing 7.5. Somewhere in here you see that it gets expensive.
Right.
So the last one's really a jump.
Yeah, so I can cruise at 6.5 on 25 amps an engine, or I can double it and get 1 more knot.
Yeah.
Well, that's more a function of the boat.
Right.
So I tend to cruise at around the 6 to 6.5 knots. I think you would find if you compared this to fuel consumption on a diesel, it gets just as expensive.
Yes.
But these I rode out only a week ago. Sat there on flat water and just checking and seeing what sort of speed I was getting compared to how much current I was pulling from a battery bank. So that gives you a fair idea as to how long the batteries will last. But the other thing that I have that is disadvantageous to battery life is I've got a 6 kilowatt inverter. And that's because you're sitting on top of a 16,000 BTU air conditioner, and there's another one in the back of the boat. And so if I want to run the air conditioners, then they're 120 volt air conditioners. The generator charges the battery bank, which is like a giant UPS, through the inverter, gives me back 6 kilowatts of power at 110. More than enough to run the air conditioners. The air conditioners will run on the battery bank for, again, about an hour. But if I've got the generator running, which I always do when I'm running the air conditioners, which is not that often, quite frankly. Here we are in 80 degrees, and it's quite pleasant in here. But the other thing we tend to do, if you look over there, you'll see there's a skillet, an electric skillet sitting on top of the gas stove, coffee pot, toaster, microwave. There's a deep fry hanging around. There's an electric cooker. You could say that propane gas is just a backup on this boat. It's mainly used for the grill outdoor.
We basically left part of the video. We talked about a lot of different things, batteries, etc., etc. But now we're going to talk about the DC genset.
Yes.
And the ability to choose and how DC works over AC as far as the genset goes.
Well, I'm of two minds of this at the moment.
Okay.
I have one 17.5 kilowatt Fisher-Panda generator, which is a one-off. So on the generator side, I don't have commonality of parts. I love the engine. It's a Kabuto V1505. It is one of the most common little diesels around. I can get parts anywhere in the world. But when you motor, if you're going to motor for a few hours, you're going to start the generator. So you're putting hours on your generator. Cheetah motoring on an electric boat, you run your generator for an hour, it charges your batteries while you're also running on your generator. Turn your generator off for an hour, run on the batteries. Generator back on, charge batteries, run boat. So in a 24-hour period of motoring, my generator only runs 12 hours. My problem is that I am producing so much current, I can push this boat above hull speed. I tend to cruise at about 6 knots. What I showed you on that chart means I'm pulling between 25 to 30 amps an engine. So I'm passionate about redundancy as well. Now my generator delivering that 25 to 30 amps plus charging the batteries still is only running at about 60%. Anyone who knows anything about diesel generators and diesels know that they love to run at near full load.
That's right.
So mine has never been to near full load. So my personal preference would be, why not have two? Two smaller ones. So when I'm cruising, the part that I like about this generator is it auto senses the battery voltage. So when I come on the boat, I just press the on button. It sits there, it thinks for 30 seconds, it preheats the generator, the diesel, starts it up. If the battery is already fully charged, it won't start. It'll sit there and it'll wait until the battery comes down to a preset threshold, which is adjustable. I've set mine for 144 volts so I don't incur duty cycles on my batteries. So at 144 volts, my generator just starts up. When it's charged, the battery's back up to 168 volts, it turns itself off. So I don't have to go out and, when I'm motor sailing for a day, keep on turning the generator on and off. I just turn it off, go. And it turns on and off every time the batteries get charged to discharge. It then automatically turns on and off. But like I say, I never really have been using the capacity of the generator.
And the choice of having two smaller kilowatts would be that one would run at full capacity to recharge the batteries, and when you motor sailed and you were under a stress load, you could go ahead and run them both.
If you needed it, you would then run them both.
Yeah.
But I would say any cruising couple, maybe 3% of the time is when both would actually come on.
Yeah.
Now, as long as you've got an intelligent controller controlling both, then the controller will flip between the generators and cycle.
And the new systems with the larger boats, the 60-foot catamarans,
yes,
are now putting that into play,
that's
where
right.
They got two 15 kilowatts instead of one.
This technology is now becoming available, and they are starting to do it. Remember, this boat was built in 2003. It was the first. So there are parts of this that were very well thought out, and I think Dave did a brilliant job, particularly in the sizing of the motors to the props. Now, here's the plus. We just sailed down from New Orleans down to Key West, 4 days. While we're sailing, I can control how much power I'm producing, simply by where I set the throttles. And since I like to sort of motor sail, cheetah sailing is what I call it, I'm getting about a knot of push. But at the same time as I'm getting that push, I'm generating 500 to 600 watts of power, 2 to 3 amps an engine at 168 volts. And because I've got a lot of electronics on this boat, and because we tend to cook with electric, I'm replacing all of that power without the generator ever running. So I'm actually sailing a bit quicker than the boat would sail if it was just a regular sailing boat with diesel engines, and I'm producing all this excess power. The longer